Hi everyone, and thanks for coming to listen. We want to talk a little bit about service function chaining. And we want to talk, well, I won't do that yet. First we'll let ourselves introduce ourselves. Brady.
Hello, I'm Brady Johnson, project lead for the OpenDaylight Service Function Chaining project. Also OPNFV SFC project. Present this today with Chris Price. I think this will be a lot of fun. Some theoretical concepts here. See how that works out. Yeah, present yourself.
I'm Chris Price. I used to be a committer on Brady's project until he removed me.
You didn't do anything.
I work at Ericsson. I work at Ericsson as well. I'm actually Ericsson's representative on the technical steering committee at OpenDaylight. Former committer on Brady's project, and former committer on Abhijit's project. Both my project leads kicked me off their projects. It's terrible. But we want to talk a little bit about service function chaining. So service function chaining, it depends where you come from and how you see things as to what you believe service function chaining is all about. I've been reading the RFC. There is an RFC. Go and read it. It talks about service function chaining, and it doesn't say a thing about SDN. It's really just, we have different types of entities in the network. We have service functions. We have service function forwarding entities, which are forwarding and aware that they're part of a service function chain. And we have service function classifiers, which are aware that they're going to be receiving traffic and have to put it onto a chain in some way, shape, or form. And it's quite simple and relatively straightforward until you read the spec. But it doesn't talk about how to make that happen, how to do that. What is a service function forwarder? Is it a particular type of switch, or is it a router, or is it a VM? What is it exactly? How does it work, and how do I implement it? And in the spirit of open source, the IETF is actually very good at the spirit of open source. They don't define this. They basically say, these are the things that we need to see existing. Someone's going to build them. And of course, in open source, we go about building them. So Brady's group have been focused on doing a lot of work in OpenDaylight around how to build these structures and architectures and essentially represent that IETF implementation at that level, and then build rendering solutions underneath which talk to the forwarding plane, while working with OVS, for instance, to get some, well, we still have a pending patch?
It's been 2 years now, yeah. Still pending.
Pending patch. So we have a patch which has been pending in OVS for about 2 years, yeah. Which would then support this encapsulation.
We're going to talk to them today at 2 o'clock, so that'll be
very good. That'll be a pleasant conversation.
Join the fun, yeah.
Bring weapons?
Maybe, yeah.
So what I want to do, actually, so as Brady said, I'm going to talk a little bit about the theoretical stuff and some propositions. Brady's going to talk about what actually is happening and what's going on. So I'm going to let Brady talk and say where we are. Then I want to sort of propose some things and talk about where might we be wanting to go. What are some of the weird things that we might want to see happening? And then we're going to come back to Brady, and he's going to sort of say how we would actually consider doing things like that. So I'll hand over to Brady for a little while and
okay, thank you.
Stand to the side.
So composite use cases, as Chris mentioned, we're going to consider extending the domain of SFC. I mean, right now, today, the domain is basically in GI LAN and in a data center, and it's not reduced, but in a particular domain. So talk about extending that across multiple entities. How do let's see, just press that. Yeah. Oh, wow, it works. Okay. So before we get into that, let's talk about where we are today and what we have available. So today, I mean, looking at this list, actually, I was thinking about it before the presentation. It doesn't look like much, but it's actually taken us a good while to get here, right? So today, we're using OpenFlow for everything. Since Lithium, we've had the OpenFlow renderer. The renderer is what is programming the switches, the OpenFlow switches. We call them renderers in OpenDaylight. The main use case of this OpenFlow render is VXLAN GPE with NSH. And this NSH and VXLAN GPE patch is what we're waiting to get into VMware. And we have limited MPLS support available today, very limited. So we need to do some work there. FIDO. FIDO VPP, it's a new sort of software switch that Ed Warnicki's around evangelizing quite a bit. If you haven't heard about VPP yet, then you're maybe just not listening. But I think Ed is everywhere yelling, FIDO, VPP. It's actually very cool stuff. And
stand next to Ed for 5 minutes and you'll get the whole picture.
Yeah. It only takes about 30 seconds.
All right.
But he actually has a FIDO day all day today, presenting what it is, how to get involved, and how to use it and such. So that's coming in Boron. They've started working on that. Then there's another render in iOS XE Cisco stuff. So that's the renders we have today. And I mentioned the domains. What domains do we have today? Basically in data centers and in the mobile operator GI land is where we are focused today. And obviously we can achieve this in OPNFV. So I'm working in the OPNFV SSC project as well. And the idea there is to take the OpenDaylight SSC project and integrate it into the cloud environment in OPNFV. So, and as I mentioned there, I mean, the OPNFV, the current use case is with OpenStack. So, right. So what is a composite service chain? As I mentioned before, consider extending the domain of what SFC does. And this is an example here. You could go over an Ethernet network, then MPLS, VXLAN, across different types of service function forwarders, and we'll get into a bit more detail.
Let's lament over this for a while before we move on. I mean, so today we sort of talked through, we have a render, it's taken us quite a while, we have some support in the vSwitch, and well, we have unofficial support in the vSwitch for this piece right here.
Yeah.
So that's what we have today, and it's taken us quite some time to get there. We have an architecture in place, we have renderers in place. It's not so straightforward to build that. And then what we're saying is, okay, if I want to use this for different types of use cases, I'm going to have to be able to do encapsulation on MPLS and encapsulation in Ethernet network. How does that look? All right. And what role does the SFF play when I'm transitioning from one encapsulation or network type to another? And to be honest, it becomes rather complex. We know how complex it is because of the work we've done just with the VXLAN-based encapsulation. So the actual question when I start to raise this, let's build composite service chains, let's do MPLS, let's make MPLS talk to VXLAN, because then I can come into the data center with one deployed service chain and I'm happy because I only need one classifier at the beginning and I don't have to worry about gates and things like that. And people look at me strangely and there's like, why the hell do you want to do that? And it's a really strong why. It's like, don't talk to me about this why. You know, we have gateways that do that for us. Please, let's just do that. You can do your service chains here, and then you can do your service chains there. Orchestrate it at a higher level and use the gateways to solve the problem. That's how we do networking. Yes, it was, and it may still be, but we need to explore whether it really is how we're going to continue to do networking. We have SDN now. We have the ability to reassess how we're enforcing, how we're gating, and how we're translating. If I'm simply translating one encapsulation type to another because I know I'm on a chain that I can enforce that is going to end at an enforcement point, why do I need a gateway in the middle anymore? Is that even necessary if I can just translate within the context of a secure service chain? We sort of have to reassess this. And interestingly, if you read the IETF spec, it doesn't talk about service function forwarder as anything other than I am going to forward to a service function or I'm going to forward to the next service function forwarder that I know is near the service function itself. There are other things we need to explore in that area, and maybe they don't belong in that RFC. Maybe we need another RFC to talk about encapsulation translations. But still, it's worth discussing. So again, why the hell do I want to do that? To be honest, I put this slide up a few times because every time I have the conversation, we move forwards a little while, everyone takes a deep breath, goes home and sleeps, and we come back the next day and it's like, why the hell do you want to do this? It's so complicated. Yes, it is. Maybe it's not. Do we just want to use vSwitches? Why not use vSwitches? If I solve the problem with vSwitches, maybe I have white boxes in the network and I run OVS out there and then I can just OpenFlow my whole network end to end. Any network engineers here who want to OpenFlow the network end to end? Just please raise your hand if that's something you're endeavoring to achieve. Because I don't necessarily believe that's where we're going. I think there is still room for other ways of interacting with the network, especially in a wide area network where I don't really want to be programming the entire forwarding table of a WAN. So I guess we've talked a little bit about it. We talked about the fact that we're different encapsulations. The question is, why do we have different encapsulations? If I think about a service chain in the context of what we're doing today, we do it in the data centers, VXLAN encapsulation. We come in, we hit a gateway, we bounce into the network, and we're just running over various VXLAN encapsulations, hitting SFFs, playing with our NSH header, and moving along in invoking these functions. Solves a problem in the data center that I'm not 100% confident that I actually need to solve in the data center, to be brutally honest. But I'd like to question things. I leave that alone. Yes, we do it in the data center. There is enough interest for me to believe that we need to do it in the data center, so let's continue doing it. What else do we need to do? We need to think about the end-to-end network. We need to think about, if I come in from a baseband processing unit, or if I come in from a CPE, where do I go next? And today, we go to the gateway. We go to the enforcement point. It's going to be somewhere. That's how we do things. If I don't need to enforce anymore, if I don't need to gate in the same way, if my gateway can be wherever it needs to be, because I have NFV, because I have the ability to spin up an application where I need it, I even have the ability, if I want to gate and enforce at the CPE. Then, how do I go? How do I take advantage of my network? How do I look at different use cases? So we sort of did a little bit of exploration there. Did you want to talk through it, or do you want me to talk through it?
Go ahead.
Cheers.
Yeah, go ahead. You're doing great.
So
animation didn't work.
We start with some sort of access, and we start with some sort of classification. This is mandatory. If I come into the access, I have to be able to classify if I'm going to do any sort of service chaining. I cannot do chaining unless I've classified. Rule number one.
What does a classifier do?
It classifies.
Yes.
So basically, the role of a classifier, it takes a piece of traffic and it identifies which chain to put it on, or not to put it on and just throw it out on the internet somewhere. So the classifier has the role of identifying which chain ID I'm going to be forwarding the packet along. And let's say my service functions that I want to get to are way over there in a data center somewhere. That's cool. What I define is a service chain. The first thing is, here's my service chain, and this is what I want to do. I want to connect these things together. And the service chain is kind of an abstract concept. Sorry. It just talks about what it is you want to do. Connect this to this. It's pretty straightforward. I can then define a service path, optionally, and a rendered service path. And these will talk more about the path the traffic has to take when it's traversing a particular chain. Or I could have a series of chains which provide a series of paths which my classifier may be able to choose from. It's not really terribly interesting. Brady was adamant that we have multiple service functions because you don't have SFFs without service functions. Fair point. I just put them in a line because I'm used to drawing routers. So at the end of the day, I have this wonderful service path. And if I'm coming in from an access point, my CPE, it's sitting in my house. It's not running VXLAN with NSH. It's not in a data center. It's well removed from where I want to be. Generally, it can be going over an Ethernet type access, and then I may be moving into an MPLS encapsulated type transport solution, and then eventually I might hit a VXLAN. Thank you. MPLS TP. Okay, so different region, same story. It doesn't really matter. You will have different types of transports and different types of encapsulations that you need to address. We have two ways of doing this. One way is, okay, here I have service chains. Here I have service chains. And here I have service chains. I just do my service chains in the domains where I can render them simply and I understand it. And that's kind of okay. I can do that if I want to do that. And then I can just, at the next level up, the management level, I can basically say, okay, please build these service chains and OpenDaylight will go off and render them for you. You still need the renderers. And the question you have to ask yourself is, if my job as a service function chain is to connect two abstract concepts together, what am I connecting here? What is my service chain telling me? All it's telling me is get to here because he's going to know what to do next. And so that's a function then, to some extent. I can argue that I have a function here that's going to do something. It's going to figure out where to go next. Maybe it's classification. Maybe that's what it is. It could be an SFC. Then I can go back to my service chaining architecture and I can say, okay, given that I know I have a service function here and I have a service function forwarder and it's part of the process of getting me to something that I actually want to get to, well, this is actually part of a bigger service chain. So why don't we look at the service chains in an end-to-end WAN context? Then I can conceivably think, okay, my home network is connected up. I have my carrier's data center somewhere which I'm connected up to, and I have service chains which connect me and my kids to these, potentially also connecting me to other assets in the network. Depending on what level of authentication I need to get to those assets. So there is a question of security that comes into it. So if we accept that we want to do end-to-end service chains, we want to be able to define a service chain which is connecting an entity out here, you know, a container running on a CPE to a bunch of service functions running in a data center. If we accept that that's something that we want to be able to chain, this is more or less what we need to do to get there. We have to build a bunch of gears that provide us with an MPLS TP service chain rendering engine. We have to have a service function forwarder which is able to do translation from this encapsulation to an MPLS-based encapsulation, which may have some service functions along the line as part of a service function forwarder, re-encapsulated, and then when I get to the data center, I want to hit a VM which is able to take my MPLS and then re-encapsulate that into a VXLAN-based solution. Do I need gateways for this? I certainly need routers. I need switches. Do I need gateways? It's a real question. Where do my gateways need to be when I'm doing this? What am I authorizing people to do in my network? Traditionally, we've gone from access to gateway, and then we've done everything because everything was built in boxes. Things aren't in boxes anymore. So I don't necessarily just have a line straight to here, and that's how I get access to the network. I can change this. I can adjust how this looks. So composite service function chains are actually a tool that we might want to leverage in order to take advantage of NFV, in order to take advantage of the fact that I can virtualize a workload here, probably virtualize a workload here. I mean, this is a white box now, right? Or a bright box, or whatever it's going to be. It can run different things depending on what I need. And as an operator, I can choose how I'm going to structure my network to accommodate that.
We'll do the slides.
What's that?
No.
You can do this one?
I said I'll do this. I'll advance the slides for you then.
Oh, you'll advance slides. OK, cool. So,
I was wondering, secretary or anything.
Whoa. Yeah, well, keep going, actually. We've lost the... Keep going. There we go, finally. OK. Sorry, the first thing we did was define a service chain that didn't end anywhere. That was kind of a bad thing. So let's take the slide in as complexity. So if I start to think of how I take advantage of the network, maybe I have CDN near my access. Maybe I just dump all the Netflix stuff out remotely and just say, OK, this is where I want everyone to go for Netflix because it's killing my core network every 8 o'clock every night. So I want to be able to tell my consumers from their CPE at home that, OK, if you want to do anything, you're going to hit a service chain. And my classifier needs to know some things. It needs to know that there are things in the network. So I tell my classifier, if anyone's going to Netflix, we've got a Netflix server here. I don't want to gate them. I don't want to run them through any of my VMs. I don't want to daisy chain the stuff in and out of data centers. This is killing my network. East-West is going to destroy me. I would prefer that they just went straight to here. I've deployed it in the network. I don't want to authorize. Netflix does that for themselves. I know they're going to use the service. That's actually pretty straightforward. And from a business case perspective, it makes a lot of sense, at least to me if I have contention problems with or congestion problems in the network. So what I might want to do is define a service chain which only goes so far. So when I come into the classifier, I basically say, OK, any traffic in the classifier which is Netflix goes straight here, and I don't worry about it, and it's done. I still have my end-to-end service chains, and they still require rendering. But here I may just be using an Ethernet-based rendered service chain for my CDN network, and then I may be using Ethernet to MPLS to VXLAN for my advanced services in the data center. So there's more than one type of use case. There's different ways we can take advantage of this. And here's an example, just CDN. It could be anything. I mean, another example that I like to sort of talk about is automotive. When I have a bunch of cars driving down the freeway and they're all connected to LTE and they're all talking to each other, and I want to participate with my car via my phone, for instance, I need to be authenticated to participate with my car. I don't want the guy next to me sort of to start participating with my car. That's not really what I have in mind. So I do need the ability to be able to authenticate, to be able to set up secure connections. I need to be able to say, OK, you can talk to these things, and you can do so trusting in some things. So service function chaining security, which is something coming in very shortly, is going to play a key role in this. But what it enables you to do is to set up connections in the network that you can trust, and that you don't need to route in through some gateway or in through some data center somewhere. I can actually do this out in the network because I'm able to essentially create tunnels on demand. Ethernet connections on demand is something which is one of these concepts is coming up. I think it's being a little, it's not being understood in the right context. This is such a commodity thing. People People are thinking, I want to be able to buy, a 1 gig Ethernet connection on demand for like 6 hours. Okay, sure. I want to be able to create tens of thousands of Ethernet connections on demand for secure connective services that don't have to spin into a data center somewhere. That's what I would like to be able to do with my access network. That's going to save me a whole lot of trouble in the aggregation side. And if I do have congestion in the core, it's just going to remove that from everything. And if I'm talking about my phone talking to my car or one car talking to another car, I don't want latency and lag through the data center. I want immediate, trusted communications in the access side. So these are some of the things that this type of technology, once we get there, actually serves some of these purposes. It's very hard to sort of articulate that because we don't have a good picture of how that network looks yet, but the concept kind of could fit over how we choose to do so. So how do we get here? So the problem is, again, coming back to reality, we have most of this. None of this, and we haven't started on this. How do we get there? Just add renderers. Okay, we know how to talk to the renderer that talks OpenFlow vSwitch, so we have that model, we know how to talk to it, it's cool, it does what we like. Let's do that for Ethernet. Ethernet's not the same. I can't program my forwarding tables the same way in Ethernet. Damn it. MPLS is not the same. I have to actually ask for routes and stuff. Am I going to use segment routing? Is NSH encapsulation enough? Not so straightforward, actually. So the renderers need to be done, and they need to consider the technology that they're being built on. Additionally, the renderer needs to be aware when it's rendering against another type of technology, because the service function forwarder needs to be aware that it's going to be receiving an encapsulation and sending on another encapsulation. And that can require cycles of effort on behalf of that forwarder. That's something that we haven't really explored yet either. And that maybe it's the future gateway, who knows. But to render a path, you really need to know something about the network upon which you're providing encapsulation. It's not just straightforward, and that's why it's taken us so long for the VXLAN stuff. It's the first time we ever went through this process, but having gone through that process, it puts us in the driving seat to expand our capabilities. Good.
Yeah.
Back to you.
So what will it take to get there? I mean, Chris covered this briefly. Should we call this a call to arms? As of yet, what we're discussing here is somewhat theoretical. So
you don't believe me?
Oh, I don't. Well, no comment.
Keep going.
So, I mean, it'd be interesting to know who out there would be interested in participating in this. And what could be done and what's needed. Let me just go through all this. So, additional renders. We went over that. I mean, we need to finish the MPLS renderer. We have very limited support. It doesn't do much now. So we need to complete that. Additional renders, Ethernet, like Chris mentioned, and whatever other renders we could come across, whatever other sorts of switches and such and transports. We need this transport translation, as we saw. That it could come in on MPLS and go out on whatever, Ethernet or whatever, so we need to be able to handle that. And then obviously the big piece is the clustering. I mean, OpenDaylight gives us clustering, but we haven't ever really tested it with SFC, and we need to be able to extend this across more than just the data center, but there's a much larger context there. Domain. So, I mean, we have done some work in Boron to refactor the way that the rendering works, since traditionally it was only VXLAN GPE based. Okay? Yeah. So it was traditionally only just VXLAN GPE based, and so everything just went through that. So we refactored it, so now the concept of a render is just abstract, so we can just plug in additional renders. So now what we need is people to jump in and help out and contribute some more renders and do some studies and investigations and tests and such.
Are we confident that the plugin will support the various renderer types we need?
No, I don't know. I'll let you know when we get there. So, all right, so should we open the floor to questions?
I think so, yeah.
Yeah,
Let's
questions, please.
Anyone brave enough?
Out of curiosity, not necessarily what is legal, why not just do overlay?
Yep. Why not do overlay? So the question was, why not just do overlay? And to be honest, you are. So I mentioned a little bit at the beginning, service function chaining has really nothing to do with transport. Let's go back to one of these pretty pictures we had. That one will do. So when I need an overlay here, and I need an overlay here, and I need an overlay here, in order to support that I can choose the paths have to be rendered as overlays in order to be provided to the SFF for selection. So you are absolutely doing overlay, but what you're doing here is doing a selection criteria for which overlay tunnels you would be using for any particular packet coming in. So the service function chaining is more about the steering of the traffic, a little bit traffic engineering kind of, and the overlays, the network management or network engineering piece is done by the renderers as a precondition to being able to execute the service functions, or service function chains. That kind of makes sense? And want to do overlays? You can do overlays with ACLs, right? Sure. That's perfectly fine. Some of the value that SFC brings, for instance, we're using NSH as the mechanism for doing so. What it provides you, rather than ACLs and overlays, is with ACLs and overlays, you have to sort of program each hop. If I use something like NSH, then I can basically, at my classifier, I can say, hey, I want to get through this chain. So I identify a chain. I don't necessarily know what's on the chain, but I identify that there is a chain that I want to follow, which has been pre-provisioned. So that's kind of your ACLs and your hops. So that's the rendered pieces in place. And then I have a selection mechanism which tells me which one I want to go on and has the ability to introduce metadata. So I can introduce an authentication, I can introduce a security mechanism, I can introduce just information for the services. Okay, when I go to Netflix this time, I want to make sure I got a dirty big tunnel when you get me there, so put me on the dirty big tunnel chain. You know what I mean? It's, there is additional information you can provide using service chaining. But it's, at the end of the day, it's network engineering. But what we're trying to do is centralize and simplify it so it can be done faster, done easier, than pushing ACLs and things to switches. Yeah?
Very good. Another question.
Thank you very much, Joachim Bodens on my name. My question is, how will such a solution scale? Because see, from the past, we know that connection-oriented network won't scale, so we introduce a packet-oriented network for any-to-any communications, and now it looks like you like to build the same service function and service function forwarders. So please, I'm very interested in your answer.
Does the question relate to MPLS directly, or is it service function chaining? MPLS is the introduction of circuit switched over packet switched. I mean, that was the first time we did it. We just continue to do so. I don't think. So I think that the main difference between the circuit switched and the packet switched, and we still do circuit switched in the optical network, right? You pre-program, and then you have your protection circuits, and you have your recovery mechanisms, and so on and so forth. In the packet network, we pretend to program, and then we trust the packet network to get us there. And we don't necessarily put in a protection because it's inherent in the underlay, the IP underlay. Service function chaining, for the most part, sits, as I mentioned, it's kind of over the encapsulation. So it's really not solving a networking problem, it's solving a service orchestration problem at this level. If I talk about using service function chaining in the context of an EPC, for instance, then I'm solving a network engineering problem, which is maybe a different application of service function chaining than this one. But trying to leverage the benefits of a distributed control plane such as IP in order to be able to overlay circuits. As we did with MPLS, what we're really doing with NSH is bringing in service awareness of that overlay. It's not just an overlay for the sake of the overlay, it has an actual service associated with it, so it's a tunnel that has application context. I guess that's the big difference. Good. Any other questions? Can I ask Brady questions? Oh, okay.
Thanks, guys. One question. Do you see the draft around hierarchical SFC to aid in hopping between these metadata zones? Because that seems to be the problem, the different meta at each point you go along the chain.
Yes. Is the hierarchical SFC, that's the ONF? Is that the ONF?
So it's the hierarchical, it's the draft Olsen at the minute. There's about 50 different drafts around SFC. So.
Okay, yeah, there's a bunch of them, yeah. I can understand hierarchical SFC. It's kind of punting the problem upwards. So it's instead of saying that I'm going to solve it in the renderer, all I'm saying is that I'm going to build an SFC here, and then I'm going to have something which is orchestrating on top of it. That's the other way to do it. To be honest, it makes a lot of sense. The question comes around economics at the end of the day. Do I need to buy? If I start to specialize the service chains across different technology groups, then I start to limit who can make that available to the market. And then, of course, I need to of course, find my solution, which then requires that I address multiple vendors potentially in order to address the market that I want. And then I have to find someone that can do the over end-to-end. I mean, from my perspective, I would prefer to find a solution which is able to address it in one implementation. We already have enough hierarchy well beyond SFC to have to add more layers there. I understand, certainly have no opposition to it. My preference would be personally to try and solve it in the rendering layer and just have one layer of SFC. There will be, so let me also add, I will have one layer of SFC like this. This is my orchestration layer SFC. Within the VXLAN, I might be using SFC to do forwarding between components of a network function, right? I might have an EPG, for instance, which is broken into 400 pieces, and I'm using service chaining under that, and that's not even visible to this service chain. It belongs in the context of the SF. So to me, that's not hierarchy. That's just different applications of the same technology in a different context. It's only hierarchy if one's aware of the other, in my mind at least. So yeah.
Yeah, as I understand it, one of the big problems is, like you say, is the moving from layer 2 Ethernet-style NSH headers, whether it's Meta 1, Meta 2, over to MPLS and then into VXLAN. And even NVGRE, it's how you get to talk to each other to understand the whole concept of what the service chain is.
Exactly. And that's kind of why I think we need to do this in a community like OpenDaylight and like OVS or FDIO, depending on which one takes our patches. That's why I think we need to do it here, because if we don't, we're not going to have a meaningful solution, right? We can argue about it for years and years in standards, but unless we have a reference that says, hey, it works, let's just do it this way, that's how we get progress. Especially on things like this where it could get so messy, right? That's the thing. It's not like we're just trying to create a standard here. We're actually trying to interwork a number and interleave a number of GMPLS, for instance. Let's not go there again. That was painful. Let's do it again. But no, so the reason I'm standing here and the reason I'm trying to get people interested is I think we can solve this in open source. I think we can solve this with a reference implementation that provides patterns. And those patterns can then be reused in product or just reused by open source. And that, to me, is an easy way of getting some progress.
Did you say patents?
Patterns.
Yeah.
Patterns.
Thank you, Brady. I was going to make him correct that, too. No patents and no
Except all my defensive patterns. I didn't say that. Okay. Cool. I think we're a little ahead of time.
No,
you talk too fast.
You've got a little time.
Yeah, so we can open for more questions. People can try and stump us on something. It's always fun.
Ricky always has a question.
Yeah, I'm not going to answer a question he asks anyway.
I actually have a question.
Okay.
Well, you had mentioned that you mentioned FDIO, you mentioned OVS, you mentioned need for renderer work. In your perfect world, where would that actually happen? Is it logically a plug-in to FDIO? Is that where you're expecting the rendering work to happen?
No,
or would it be someplace else? Or what is your preference?
There'd have to be two parts there. There'd have to be the capabilities in the switches. OVS would have to recognize NSH and the control plane part of that, the programmability. Then the logic would have to happen in SFC. So there's the two parts.
Yeah. And to extrapolate a little on that, I need a renderer in the controller that understands what it's talking to.
Yeah.
But I also need something that's doing the forwarding. And that's, to be honest, we haven't really talked about that, but it's really important, the forwarding piece. Let's say I'm using FDIO. FDIO is great because it has that modular architecture. I can plug stuff into it. I can create new trees. So I might have, for instance, an FDIO forwarder, which I can put out here onto switches. It's going to provide me Ethernet SFC interfaces, and I'm able to then, do that using an implementation. I may then have the same thing in the MPLS domain, but what I need here is something which is able to create another tree, which is a composite tree, which is able to map from the Ethernet rendered service chain to the MPLS rendered service chain. that's a forwarding problem that the controller can't help with. All the controller can say is, I have this and I have this, I'd like you to solve it for me, and then something in the forwarding plane has to be able to solve it. It's not a trivial problem, and it's something that we haven't really talked about because it's OpenDaylight, but certainly would go to the OVS community, certainly would go to the FDIO community and say, here is a challenge, how can we solve this? And we'll probably all scratch our heads for a couple of weeks and then sort of come up with an idea that we'll throw away in a month's time and try something new. I don't know. It's a difficult problem to solve, especially when it comes to the inline translation or inline re-encapsulation. It's not simple. We have had gateway products doing this for decades, which cost a bunch of money. It's a non-trivial challenge, which is why we don't talk about it.
Any final question? Any final questions? All right, well, thank you very much.
Thank you.